And welcome back, everybody. So we are moving through the data layers of our application. In the last video, we got a lot of data fetching set up, and we got a little bit more avatar work before we move on here. So firstly, when we go and we click on one of these, we jump into the chats view. Now we haven't set up our chat manager yet. We're going to get to that in the next section. But when we go into this chat view, we are passing in an avatar ID, which then we should be loading an avatar for this screen. So if I go to the chat view, so we pass in an avatar ID, and then we set the avatar up here. So now let's go ahead and update this. I'm going to Option Command Enter and get the canvas working here so we can see it at least in the preview. Let's go ahead and add a task, like we're doing all of our fetch requests through the task modifier. Let's create a private func called load avatar. It'll be asynchronous, and we'll open the brackets. In here, we'll do a do catch. And again, I don't want to throw an error if this avatar doesn't load. So we'll just print out error loading avatar for now, pass in the error, because really what matters here is if the chat loads. So if the chat fails to load, we'll throw an error. We'll set the self.avatar equal to, let's go into our Firebase avatar service. And we need one more method here for func get avatar. And we'll pass in the ID for the avatar ID of type string. And this one will be async throws. And it will return us a singular avatar model. Here we can say try await collection.getDocument, and we'll pass in the ID. Again, this getDocument is coming from Swiffle Firestore. So if you're not using it, you can go through and actually just call get.document.getDocument, use the as initializer, and then as type, the type would be the avatar model. So get avatar, let's go ahead and put that into our service protocol. So I'll put it up here, and then let's add one to the mock. We'll call it get avatar, and we'll just return here, add in our delay, and then we'll return avatar.mock. Cool. Let's jump back to our code now that we have our function set up in a chat view. We should be able to pull in the environment, the avatar manager .self private var avatar manager. I'll copy that, and let's go ahead, and here we will await load avatar. Here we'll set avatar equal to try await avatar manager.get avatar, get avatar. Sorry, we need to actually update our avatar manager quick. So let's take the code from get avatar. We'll add it into our avatar manager as well. Try await service dot get avatar by ID. See, while we're here, just to point out, so far we have not changed any of the syntax between the protocol avatar service and the avatar manager. You see all of these are one-to-one. We're literally just calling the function in the service. So if this was the end of our application, we absolutely could not have the manager class and just use the service class and pass this directly into the view. But between now and the end of the course, we're going to add more stuff to the avatar manager, which is why having this layer seems redundant now, but will come in handy later on. Let's jump back into the chat view. And avatar is equal to avatar manager.getAvatar by ID. I think we pass in an avatar ID, so I will paste that here. Let's go to the preview and add our .environment, avatar manager, mock avatar service. Preview should compile now. Great. Let's build and run it to a simulator, see if it works. All right, I'm going to click on Mike, and then we got Mike loading as the avatar in this chat. Nice. It even says Mike up here, so we definitely did connect something already. If I click on it, we get the profile for Mike, which looks great. Let's continue moving on here. So the next thing we're going to do is set up our recents section here. So this section, unlike the previous sections in our code, we're not going to use Firebase. We're going to use Swift data. I'm doing Swift data because I assume that a lot of people are going to have a question about how do I use Swift data with this architecture or even core data. Using core data or Swift data is very similar in how we're going to set it up. So it wouldn't matter which one you wanted to use. But this is going to be essentially a separate dependency from our Firebase dependency. And what we're going to do is every time the user clicks into a chat, so if I click into Mike, Mike is now part of our recents, and so Mike should now appear on our recent array here. I did notice that when I just clicked on this, we can see that alpha turns to Mike at the top here, and it shouldn't say alpha at the beginning. So let's just make sure that our avatar is set to nil to start, so that it's just blank if there is no avatar. Let's get the recents working, and we're going to obviously add data as well. So I'm going to do this inside our AvatarManager. All right, let's go full screen again. Let's lock in, guys. If you remember our user manager, we added two different services to the user manager, a local and a remote. So this is where we were fetching from Firebase. This is where we were saving to the file manager. So we're going to do essentially this same setup now for our avatar. We're going to have a remote for Firebase and a local for Swift data. And this way, if we want to change the local to the file manager or to Realm or to core data, we easily could do that. We also could just remove local persistence at any time. So what we're going to do here is create a second service. I'm going to do it up here for now, and we'll move it to another file later. Let's start by renaming the avatar service. I will right-click it and refactor, rename. Let's use the arrow keys to go to the left, and I'll rename this the remote avatar service. And I will Command R to build and run just to make sure that this compiles. And now let's add another protocol that I will call the local avatar persistence. I could call it local avatar service. I like the name persistence. It just makes me remember that this is basically for saving something locally. Doesn't really matter what you want to name these. Doesn't really matter what you want to name these. Below this video, I'm going to put a link for some articles about how to use Swift data if you've never used it before. I will also link you to core data. I've covered core data on my YouTube channel. I've not covered Swift data yet, but I will in the future. Swift data is much easier to use than core data. Firstly, let's go ahead and initialize one of these. And we're going to initialize it with a container. So here I'll say private let container of type model container. I will link a bunch of articles below if you've never used Swift data before, so you can get a jump start on how to use Swift data. We are not going to use any of the view property wrappers. I think that is a mistake for most developers. It's really hard to work with the view property wrappers. You can't test them. They don't work well with architecture. But this is the setup that I would recommend for most projects, where we're going to take the container and we're going to put it outside of our view, and then we'll just read and write from this container. So here I will set self.container equal to a new model container for a specific type. Now we need any persistent model.type. This is a special data model that can be saved into the Swift data container. There is a macro for this. So if I create let's create a class called myDataModel. And if I use the @model macro, this makes the data model conform to this protocol. So now I can call myDataModel.self. This throws, so I will try. And I think we just need an initializer here, and then this compiler error will go away. I'm going to force unwrap this try. And I know that I always tell people not to force unwrap, and we basically never do in our entire application, except in this instance, if we are using this Swift data container, and for some reason the container is not loading, we should crash our app immediately. I want to know as soon as I go and build and run the app that the container is broken. It should never happen, but that's why I'm okay force unwrapping here, because this basically should never fail. This data model is obviously not the data model that we want to use. We want to use an avatar model. So I will open up a second editor here, and let's go to the avatar model. Now the problem we have with the avatar model is that it is a struct. And in order to use this macro, it needs to be a class. So if I put this macro on here, you'll find that it breaks. We get, even if we import Swift data, you'll find that it breaks. Model cannot be applied to a struct. So the problem here is that Swift data and core data both require the data model to be a class. It needs to be any object. But as we know, we prefer using structs as the data models because structs are sendable and they're much easier to work with when we're working with Swift concurrency. So the solution that we're going to come up with here, which is the solution that I've talked about on YouTube and I recommend, is basically using the data model across our whole app. And then just when we are saving and fetching from Swift data, we'll convert the avatar model to a data type that is specific for the container. So the data type will basically only be used inside the Swift data code. And then as soon as we leave the Swift data code, we'll convert it back to an avatar model. This is actually very similar to what we already did with our auth service. If you remember in our Firebase auth service, the Firebase SDK was giving us a data type here called user, which was of type user from the Firebase SDK. And we basically immediately would convert it to user auth info, which we then passed around our application. So we took the remote type from Firebase, converted it to our local type, which was a struct. And here we're taking the remote type or just the Swift data type, and we're going to convert it to our struct type that we're going to send around the application. So basically I want to save an avatar model in Swift data, but I have to do it through a new data model here. Sounds complicated, but it's actually quite easy. Let's go ahead and call this data model an avatar entity. Entity is the keyword that we use when we're working with these containers in core data and Swift data. Entity is basically just a data model. And then we're going to have basically the exact same content. So I'll copy this and I'll move it into the avatar entity. Because this is a add model, there's some requirements for how we can create this entity. Let's go ahead and make this just a variable. I'm going to click up here and then Control Shift and move down, and then change all of these to a variable. When we create an avatar entity in our code, it's going to be from an avatar model. So in our init, we'll say from, and we'll pass in a model, which is of type avatar model. We'll set self.avatarID equal to the model.avatarID, self.name equal to model.name, self.characterOption equal to model.characterOption, self.characterAction equal to model.characterAction, self.characterLocation equal to model.characterLocation, self.profileImageName equals model.profileImageName, self.authorID equals model.authorID, self.dateCreated equals model.dateCreated. It's exactly a one-to-one from our model to our entity. When we go and save data to Swift data, we can apply special attributes to any of these fields. So the avatar ID is basically the ID for each model. And when I save them to core data, I don't want to save duplicate avatars. So if I save something with an avatar ID and I save the same avatar ID or the same avatar 2, 3, 4 times, I want it to only persist one in core data. I don't want duplicates. So there's an attribute here, which is at attribute, literally. And I can call the dot unique. So inside the schema, there's an attribute option. This ensures the property's value is unique across all of the models in the container. I'll just call unique here. Again, I will add links below to articles where you can learn more about these attributes. And I think that is all we need for that. We also want to do one function here called toModel that returns us an avatar model. So here I'm converting from an avatar model to an avatar entity. Here I'm going from an avatar entity back to an avatar model. And I'll just call it an avatar model. Option enter, triple click, Control M. And I could put this as an initializer inside the avatar model, but I'd rather keep all of this conversion logic in one file here. The avatar ID will be the avatar ID, the name, the character option, the action, the character location, the profile image name, the author image name, and the date created. So this is coming from the one that's already in this entity. And now we can go to and from data model to data entity. Great. Let's jump into our Swift data struct here. Let's put a function called add recent avatar. So every time we go and we click on a chat, we're going to add that avatar into our recents data container here. Basically just a local database that is saved on the device. We'll pass in an avatar of type avatar model. In here, let's say let entity equals avatar. Let's create an avatar entity from the avatar. So the initializer that we just created here. Then let's go ahead and save this to the container. So the container actually has what's called a context. We'll make a private variable called context. Let's call this the main context of type model context. This will access the container dot main context. This is basically like the main thread for the container. There's also background contexts that you can make if you want to save something on the background. The main context can only be accessed from the main thread. So what I'm going to do is actually take our whole struct and put it on the main actor. Let's go ahead here and say main context dot, and let's insert the entity into the context. And then let's call main context and we'll save the context. Every time we edit the context, we need to then save it. This throws, so let's try and let's make this throws. We'll add one more called get recent avatars. This will be a function that returns an array of avatar model. When we fetch from Swift data, there's some special syntax we need. Let's say let descriptor equals a fetch descriptor, open the parentheses, and I will option enter. We don't need a predicate. A predicate is like a filter, but the sort by, we will sort the data. When we create a fetch descriptor, there's a generic type that you need to tell it what type you are going to fetch. So the type is going to be an avatar. Avatar entity. This is the data type. And let's add a sort descriptor. And so let's create an array here. And there's only going to be one sort descriptor that we add. We're going to look for the key path in order. So the key path is basically which field in the entity you want to sort by. Let's do .date created for now. And we'll do .reverse because I think that dates, the most recent dates have the highest numbers. So normal ascending order, I think, would put the most recent dates last. And if we reverse it, the most recent dates, I think, will be first. We'll test it out in a second. We'll say let entities equals the main context dot fetch. And we need to pass in a descriptor. So we'll pass in the descriptor here. This throws, so we'll add the try keyword. And now after we have the array of avatar entity, let's convert them back to avatar model. So we'll return entities.map, and we'll map each one to data model. We'll make our function throws. And I think we can do all this on the main thread, and that's totally fine. We can refactor it if it starts to slow down our app. Last thing I want to do here is actually not by date created, but by date added. So it's the date that I most recently added this into the Swift data container. So in our entity, but not in our model, we're going to add an extra field here called date added of type date. And I'll make it non-optional so that we always add one. We'll set self.dateAdded equal to .now. So every time we go and we save one, we will update the date to .now. So now we can filter on date added. Cool. So now our local avatar persistence should have two methods, this one as well as this one. And let's conform to the protocol. While we're here, let's create a struct called mock local avatar persistence. And we'll conform to the protocol as well. Let's call add a recent avatar as well as get recent avatars. The protocol is not on the main actor, and that's why we're getting these errors. Let's actually just make the protocol on the main actor then. I think that's fine for now. Add recent avatar, we don't need to do anything. Get recent avatars, let's go ahead and return the avatar model.mocks.shuffled. Go down to our AvatarManager now that we wrote all this code. Let's rename this. So I'm going to double click on this and let's go ahead and refactor this service. We're going to call the remote. And I'll do another one, private let local of type local avatar persistence. And we will initialize this with a remote as well as a local. Self.local equals local. And just so that all of our previews don't yell at us for updating this initializer, let's just give it the default of mock local avatar persistence. So in a case where we don't add one, it'll just default to the mock. It doesn't really do anything. In here, I can now add a function called add recent avatar. Pass in an avatar of type avatar model. This should throw. And we will call try local.add recent avatar. Let's also add in a function here called get recent avatars. I think it throws as well. It returns us an array of avatar model. We'll call try local.get recent avatars. Sweet. I'll X out of the editor on the right. Let's go and test this out. So we're going to go to our chat view. In our chat view, every time we load an avatar, this would mean that the user clicked an avatar, they went to the chat screen. Every time that happens, we'll add that avatar to our user's recent avatars. So in here, after we load up the avatar, let's also go and say try AvatarManager dot add recent avatar, and we'll pass in the avatar. This is optional. To get around that, we'll say let avatar equals this, self dot avatar equals the avatar that was returned, and then we will add a recent avatar. I will make this optional because I don't really care if it fails to save locally. I don't want to print out this error for this failing. All right, so now we're adding recent avatars, but now we also need to fetch them when we come onto the chat screen here. Let's go to the chat's view. Let's get the preview working. We have a compiler error. All right, so SwiftLint is telling us that we are not allowed to force unwrap, even though I said that it was okay this one time. So we are going to fight back with SwiftLint here. And if we do a comment here and we add SwiftLint : disable, and we'll disable the next, then we can add in a rule here. So force try is the rule. We will disable SwiftLint for the next situation where force try comes up. I think that will get rid of our compiler error for right now. This is like a great example of, obviously right now we're okay with the force unwrap, but if I was working on a bigger project and a bunch of junior engineers were on the team, I don't want them adding these force unwraps all over the code. So I am pretty happy that SwiftLint is catching that, generally speaking. Let's go to our chats view. Get the screen going here. I'm going to create a private func called load avatars. Or actually, let's call it load recent avatars. We'll do a do and a catch. We'll say print failed to load recents. And we'll set recent avatars equal to try await. Let's pull in our manager at environment avatar manager.self private var avatar manager AvatarManager.get recent avatars. So every time this screen appears, we will call a .task, and we will call await load recent avatars. This should be async. Actually, I guess it is not async, so we can actually just do this on appear. In the preview, let's go ahead and add a .environment avatar manager. We don't need to add the local, so we'll just add a mock avatar service. This should compile. Cool. Lastly, let's go ahead and add Swift data to the actual runtime application. Let's go to our dependencies, where we create the ones for our actual app. Avatar Manager will add a local for the Swift data local avatar persistence. Let's build and run it to a simulator, and we will see if Swift data is actually working in our app. So I'm going to click on Steve. And now let's go to the chat screen. And just like that, Steve's already here. Let's click on Joseph. Let's click on Bella. And now we should see Steve, Joseph, Bella. Amazing. So Swift data is working just like that. We set it up. Really wasn't that hard. And we actually have a full database now in our app saving these avatars. And from here, I can go back into Steve. And now Steve is my most recent as well. This is awesome. That was pretty painless. Honestly, compared to core data, Swift data is so easy to use. I like it more and more. I did recently tweet something on Swift Data that I did not like it, and that was because I was using the Swift Data property wrappers, the @query property wrappers. I think that is a mistake. I think using those are a recipe for disaster, but using Swift Data with the contexts away from the view like we just did, like here we have the Swift Data local persistence. Something like this is much more reusable and totally decoupled from the view layer and from Swift UI. And actually, if you followed any of my core data videos, core data is essentially this. It's a little more complicated than this to set up, but it's very similar in that there's a container, there's a context, and we save and fetch special entity models. Just to recap here, every time we go into the Swift Data persistence, we convert our data model into a data entity to save it. Then we fetch entities, convert them back to data models to return back to the application. Avatar entity is a one-to-one with avatar model. This is what the code looks like. Honestly, like these add attributes are so powerful. In order to do this in core data, it would take a ton of work to unique all of the entries. I think this is doing a lot under the hood, and we have no idea. So a huge thank you to the Swift team for creating Swift Data, and in literally a couple minutes, we set up a database in our app. Let's go ahead and just clean up these files before we end the video. So our services here. So we have our avatar services. Let's go ahead and create a folder called remote. And I will put all three of these into the remote folder and one more called local. And let's take our local avatar persistence, put it in here. Let's take our mock persistence, put it in here. And let's take our Swift data and put it in here. Lastly, let's take our entity, avatar entity, cut it, and I'll move it into the models folder here. Let's go ahead and import Swift UI. I will Command R to build and run, see if we have any compiler issues. And we do, because we need to import Swift data here. I think we might also need to import Swift UI here. And yellow white space warnings. Let's go ahead and delete that. I'm just going to go through the Swift lint warnings that we have here. Command R, it should build and run now with no warnings or errors. And great. So it's that easy to set up Swift data. We have an entire local database in our app, and it is working exactly as expected. Let's go ahead and Option Command C. I will make this a feature, and we'll go ahead and say local avatar persistence. Let's stage it. Let's commit it. Push it up to GitHub, and I'll see you all in the next video.